Hey guys, we are moving on into chapter 6. Chapter 6 is kind of fun. We get to study what are called oblique triangles. Up until now, everything we've done with triangles has been a right triangle, meaning that you have that right angle. Well, not all triangles have a right angle. And so in chapter 6, they're going to give us formulas for how do you find missing sides or angles of what are called oblique triangles. And how do you find the area of a triangle if you don't have that 90 degrees. Okay, so today we're going to start off with a process called the law of sines. And then later this week, we will look at a process called the law of cosines. Okay, so super cool. Back in chapter 4, when we really studied triangles, it said we studied various techniques for solving right triangles. Now remember, a right triangle by definition means you have to have a 90-degree angle. Well, in section 6.1 and 6.2, so today and then again on Thursday, we are solving oblique triangles. And oblique triangles are triangles that have no right angles. So you can't use SOHCAHTOA and you can't use 1/2 base times height. So that's where the law of sines and the law of cosines are going to come into play so we can continue to find missing measurements of triangles. Kind of fun. In standard notation, the angles of a triangle are labeled with the capital letters A, B, and C. Their opposite sides are lowercase a, b, and c. So just in case you're like, what the heck does that mean? Here's a visual. So notice the angles are uppercase, the sides are lowercase. Your A's are always going to be across from each other. That's what they mean by opposite. B's are always going to be across from each other. C's are always going to be across from each other. So as they give you the problem, you'll know if they're talking about the side or the angle based off of, are they using a capital letter or are they using a lowercase? Capital means the angle, lowercase means the side. Okay, to solve an oblique triangle, and if something is solved, it means that you know everything about it. So you know every side measurement, every angle measurement. Well, to solve an oblique measure, you do need to know at least one side. So it means you might know one side, you might know two, heck, you might know all three, but you have to know at least one side, okay? And then the measures of any two other parts. So you could have one side and two angles, or you could have three sides, or you could have two angles and one side. But the main thing is, it doesn't work unless you know at least a side, okay? Here are 4 cases where we will be able to solve an oblique triangle. Okay, this is going to take you right back to geometry proofs. If you have 2 angles and one side, you have angle, angle, side, or angle, side, angle. Remember those proofs? Here we go. Don't worry, you're not doing the proofs. These are just the scenarios, okay? 2 sides and an angle that are opposite of them. So side, side, angle, make sure you keep that in that order. Side, side, angle. Gotcha. Okay, you're smiling. Perfect. 3 sides, side, 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 or 2 angles and or 2 sides and their included angles, so side, angle, side. Now, when we are looking at the first 2 cases, that's where we have to use the law of sines. Sorry, I was writing and talking at the same time. Law of sines. So if you have angle, angle, side, angle, or side, side, angle, it's the law of sines. The last 2 cases, they require what's called the law of cosines. So if you have side, 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 and side, angle, side, that's where the law of cosines is going to work. And that's what we are going to cover in here on Thursday. Okay, but first, let's just go ahead and look at the law of sines. Again, here's that visual. A is across from A, B is across from B, C is across from C. Always 100% of the time. Your angles are uppercase, your sides are lowercase. Now, what you can do is create proportions. Now, remember, proportion, by definition, means that you have 2 fractions with an equals in between them. And the reason why it's nice if you can go ahead and set up proportions, you can easily solve them using the process called cross multiplication. So what they're showing you, and they show you that you can do this either way. You can take side A over the sine of angle A, side B over the sine of angle B, side C over the sine of angle C, or you can do their reciprocals. Okay, so they're just showing you that these 2 things are actually equivalent. They mean the same thing. you have to pick, okay, are you going to do the angles on the top and the sides on the bottom, or vice versa? 90% of the time when you look in math books, it's going to put the sine of the angle over the side, okay? But they just want you to realize that it is equivalent as long as you are consistent. If you want to put the sides on the top, great, but you have to make sure you always put the sides on the top. If you want to put the angles on the top, great, but you need the sine of the angles always on the top, okay? This is the first book that I have ever looked at that showed you both methods. It does make sense because it's equivalent, so it's a really good tool. Any other book that I worked with, and even when I was going to school, they always had the sine of the angle over the side. So for that purpose, when we go through the examples, I'm going to do this because this just feels upside down to me. This is still correct. So if you like this better, you go for it, okay? I will be doing this one. Okay, so let's go ahead and see, well, how the heck do you do this, all right? So you have to create a triangle where C is 102.3 degrees, B is 28.7 degrees, and side B is 27.4 feet. Okay, so you're gonna go ahead and draw a triangle. Obviously, you guys, don't worry about your triangles being accurate, okay? Just plop a triangle down. The main reason why you have to draw it out is because we are supposed to solve the triangle. Solve means you know every measurement on the outside and every measurement on the inside. Well, without drawing it, it's kind of hard to make sure that you know everything. Okay, so I'm going to say this is A, this is B, this is C. So that would make this B, that would make this A, that would make this C. Okay, so I went ahead and I just drew out what I know. Okay, I have just the template for my triangle. Angle C, this is 102.3 degrees. Angle B is 28.7 degrees. Side B, this is 27.4 and the label is feet. Okay, so that's what I know. Now you have to solve. Solve means you want to know everything about it. Well, measure of angle A, that's going to be really darn easy to find. Even if you don't have a right triangle, every single triangle always adds up to 180 degrees. So I know two measurements, two angle measurements. I can say 180 degrees minus 102.3 degrees minus 28.7 degrees. Whatever that is the measurement of angle A. Now, one thing, guys, depending on what you were doing last with your calculator, because you are in the class where you switch back and forth between degrees and radians, we are now looking at triangles, not the unit circle, okay? So you want to make sure you hit that DRG button and make sure that your calculator is in degree mode. Because if you were to do the law of sines or the law of cosines in radian mode, it's heartbreaking, but every single answer would be incorrect. So you want to realize that, hey, we're looking at triangles. Look at our labels, they're degrees. Your calculator must be in degree mode. Okay, so let's find the measure of angle A. 180 minus 102.3 minus 28.7. Measure of angle A is 49 degrees. Okay, so I have that. So now I know all three measurements on the inside. I need to know the measurements on the outside. Now here's the law of sines. This is where you get to create what's called a proportion. You want to find where you have an angle and the side opposite. So in our case, it's this. I can turn this into a fraction because of my law of sines. So I'm going to take the sine of the angle. So the sine of 28.7, that goes over the side that's across from it. So 27.4. Now I can use that to find my two missing sides. So I'm going to go ahead and write that fraction two separate times because I'm going to need to use it twice because I'm missing two more bits of information. Okay, so when you write your triangle, you start off with information where you know the angle and the side across. It's the sine of the angle over the side. The sine of the angle over the side. Now, if I want to find side A, I have to use angle A because remember they're paired with whatever's opposite of them. So it's the sine of the angle, so sine of 49 over the side. Well, that's what we're trying to find. Now remember, when you have proportions, what you do is you cross multiply. So if I cross multiply, I have A times the sine of 28.7 equals cross multiply. I have 27.4 times the sine of 49. Now what I want to do here is solve for a. This is a times the sine of 28.7. So I just have to go ahead and divide it to both sides. That way this would cancel, so a equals. Now you can put this in your calculator. One thing you want to do is enter the top and hit equals, then divide by the bottom. Just so that way it's not so much information for your calculator. You'll have a less chance of having a mistake there. So 27.4 times the sine of 49 equals. So that's the value of the numerator. Now divide it by the sine of 28.7. That's what side A is. Okay, I'm going to round to the 10th. It doesn't tell us how to round, so if you want to go to the 100th, great. If you want to go to the 10th, awesome. Just please be consistent. Okay, so I'm going to go to the 10th. So 43.06 would be 43.1. Our label is feet. So I know side A. So now I can come over here. Side A is 43.1 feet. Now I'm missing one more measurement. I need side C. So in order to find side C, you have to use angle C. So it's the sine of the angle, 102.3, over the side. Now I can cross multiply. I have C times the sine of 28.7 equals, cross multiply, 27.4 times the sine of 102.3. Now to solve for the sine, to solve for C, this is C times the sine of 28.7. So in order to undo multiplication, you have to divide. So divide by the sine of 28.7. So C is alone. We're going to go ahead and put this in the calculator. Remember, after the top, hit equals. So 27.4 times the sine of 102.3 equals. That's the value of the top. Divided by the sine of 28.7. Ooh, 55, I'm rounding to the 10th, 55.7 feet. So I'm going to come over here and write down the measurement, 55.7 feet. So right now, this triangle is said to be solved. The reason why it's solved is because I know all three angle measures on the inside of the triangle, and I know all three side measurements on the outside of the triangle. One way to kind of check your work. The biggest angle should always be across from the biggest side. Okay, the smallest angle should always be across from the smallest side. So if you look, 102.3 was our biggest angle. Our largest side measurement was 55.7. They are across from one another. My smallest angle is 28.7. My smallest side measurement was 27.4. They are across from one another. So that's just a way to go ahead and check your work. That should be consistent all the way through all of the problems. All right, let's turn the page. Yes. Okay, now here's a real life scenario, because I know sometimes as we're doing these problems, you're like, oh yeah, this is kind of cool, but when would I ever use this, okay? So let's say that somebody put up a pole, whether it be like an electrical pole or something like that. And what happened is with the wind or a storm, it ended up tilting. So when they originally built it, what happened is it was 90 degrees. Or maybe the snowplow went by and knocked it on over, okay? So what happens is it says the pole now tilts toward the sun at an 8-degree angle from the vertical. So it's no longer vertical, it's 8 degrees from that. So what that means is from the horizontal, it was 90, now it's tilting an additional 8. So this angle is now at 98 degrees. I hope that makes sense. So it was 90, now it's tilting 8 more degrees outwards. 90 plus the 8 is 98. Okay, so we have that. It casts a 22-foot shadow. So you'll see the side measurement is right there. Okay, it's 22 feet. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. Remember, angle of elevation has to go from the horizontal, and you're looking up to the top of the object. So this is your angle of elevation. They told us it's 43. We want to find out, well, how tall is that pole? Okay, so again, we're going to use the law of sines. Well, here's the deal. I have this angle, but I don't know that side. I have this angle, but I don't know that side. I have this side, but I don't know that angle. Well, you guys, we can find this angle super fast because I know 2 angle measurements inside of the triangle. And every single triangle, whether it's a right triangle or an oblique triangle, it adds up to 180. So I can start off by figuring out the measure of angle C. It's 180 degrees minus my 98 minus my 43. So 180 minus 98 minus 43, you get 39 degrees. So this is 39 degrees. Now I can create a fraction using the law of sines because I have an angle and a side opposite. Okay, you have to have that in order to create a fraction. So I have the sine of the angle, we just calculated, that's 39, over the side that's opposite, that's 22. Now what they want us to find out, we're not solving the whole triangle here. We are just answering a question. How tall is the pole? Well, that's A. Well, if I want to find side A, I have to use angle A. So it's the sine of angle A, which is 43, over the side, and that's what I'm trying to find, it's A. Cross multiply. So A times the sine of 39 is A times the sine of 39. 22 times the sine of 43 is 22 times the sine of 43. Now again, if I'm trying to solve for A, I need to isolate it, so I'm going to have to divide both sides by the sine of 39. So here my writing got stuck in that object, so I'm just going to rewrite it for you. So it's 22 times the sine of 43, then I ended up dividing by the sine of 39, just to make sure that you can see it. We're going to enter the top, hit equals, and then go ahead and divide. So I'm going to go ahead and do that, and it will tell me the height of the pole. 22 times the sine of 43 equals, that's just the top, okay, you're not done. Now divide it by the bottom. The sine of 39, that pole, you guys, check this out. A is 23.84, so I'm going to round to the 10th, 23.8 feet. That's how tall that pole is. You just answered a real-life scenario by creating a proportion using the law of sines. Super cool, okay? Now, there is kind of a little stinker case. It's called the ambiguous case, and that is the side angle, always in that order. I hear those snickers. That is always in that order. So if you have side A, what happens is three different things can happen. So before you go ahead and start trying to solve, you have to figure out, okay, is this possible? Because some of them are not even possible. Is there one solution? If there is, go for it. Use the law of sines, find your one solution, solve the triangle. If there's two solutions, because that's the other option. If a certain scenario occurs, that means that there's actually two triangles that would satisfy those measurements. So it's kind of wild. Okay, so again, if you have two sides and an angle not in between, you might have no such triangle exist. And here are two examples of what that would look like. The measurements just don't line up. The triangle would not be able to close. Okay, so it's not even possible. You might have one triangle exist. Well, here's a triangle, here's a triangle, here's a triangle. Perfect. Okay, so there's a few scenarios where you just get one triangle, and then the process will be similar to what we just worked through. You might have two triangles, and what that means is when you're looking at A might be tilted in, meaning the angle is, or your angle B, because it's across from side B. This could be obtuse, or side A could be out here, making B an acute angle. So it's possible that you could also have two solutions. So before you start, you want to know, okay, do I have one solution? Go ahead and solve it. Is there no solution? Just write no solution or not possible. And then you're saving yourself a whole lot of work. If it's two, you got to be ready to go ahead and draw two separate triangles for this, okay? So you have side A. It says consider a triangle where you are given side A and side B and angle A. Remember, your angle is capital. Now, one of the things you'll see is that they're talking about H. There's H, there's H, there's H. Well, what the heck is H? Well, H is equal to side B times the sine of angle A. Okay, so one thing is you'll want to go ahead and calculate that. You need to know side B, side A, and H. Now, if A is smaller than H, there's no solution. If A is less than or equal to B, there's no solution. So there's two times where if this occurs, if A is smaller than H, or if A is smaller than or equal to B, there is no solution possible, right? Not possible, move on. If A is equal to H, or if A is greater than or equal to B, or if A is greater than B, there's one triangle. So you draw your triangle, solve it like we have been. Now, if H is the smallest, A is the middle value, B is the largest, there are going to be two solutions. So again, it has to go, if you're putting them in numerical order, H is smallest, A is the middle, B is the largest. If that happens and none of the values are equal, okay, they have to go in that order going least to greatest, then you have yourself two possible triangles, okay? We're gonna go ahead and do this. It says for a triangle where A is 22, B is 12, and angle A is 42, find the remaining sides and angles. Okay, well first we gotta make sure that it actually exists. So let's start off, we know A. A is 22, they gave us that. B is 12, they gave us that. Now the other thing we have to know is H. H is side B times the sine of angle A. Well, side B is 12. Sine of angle A, they told us angle A is 42. So I have to go ahead and calculate that, and that is going to be our value for H. 12 times the sine of 42. So I got 8.02. So if I'm rounding to the 10th, it's just 8. So now let's look, okay? Is A smaller than H? Nope. Is A equal to H? Nope. Is A greater than or equal to B? Yes. Okay, it's only going to fit one of these. Well, here, A is greater than B or A is greater than or equal to B. Either way, you have one solution. So we do have one triangle. So go ahead, draw it out, and we can use the law of sines to solve. Okay, so let's say this is A, this is B, this is C. A, side A, so across from angle A is 22, and it's in inches. Angle B is right here, so side B, 12 inches, is across from angle B. Angle A is 42. Now this time, notice we do not have two angle measurements. This is all we know. So we're going to have to go ahead and use the law of sines right away. You can use the law of sines to also find missing angle measurements. I have angle A and side A, so that's where I can make my fraction. So I have the sine of 42 degrees. It's the sine of the angle over the side equals, let's say I want to know angle B, okay? Because I already know side B, so let's go ahead and find angle B. So if I have sine of angle B over the side, which is 12, it's okay to have your variable as the angle because we don't know that. Cross multiply. So I have 12 times the sine of 42 equals 22 times the sine of B. Now what I need to do is solve for angle B, so I need to isolate this. Well, first I would go ahead and divide by 22. So I'm going to come over here, 12 times the sine of 42 equals, that's the top, divided by 22. Okay, so this is 0.36 equals the sine of B. Now if I want to get rid of a sign, remember we had that inverse sign? So on your calculator, what you have to do is hit second sign. You'll get that little -1. That means it's an inverse. It means that you're canceling one sign, so angle B would be all by itself. So the way that you enter this is second sign. I cancel the sign. Sorry, the kitchen light is blaring here. Okay, the sign of -1, 0.36, I get, 21.1. So that means measurement of angle B is 21.1 degrees. And again, depending on how you are rounding, you can get a variation of answers, but it needs to be close, okay? So let's say you rounded this to the 10,000ths instead of the 100th, or maybe you rounded it to the 10th, or maybe you rounded it to the thousandths. You might get like 21.2, or 21.3, or 21.4. But either way, it's going to be around 21. So again, when you're doing this, because of the rounding, these are approximate answers, okay? So I have approximately 21.1. Now, hey, I can find the measurement of angle C because I have two angles. Every single triangle has to add up to 180. So 180 minus 21.1 minus 42, my measure of angle C. 180, oops, there we go, 180 minus 21.1 minus 42. My measure of angle C is 116.9 degrees. So this is 116.9 degrees. So now I have all three measures on the inside, two measures on the outside. You guys, I'm still missing the measurement for side C. So I have to go ahead and use the law of sines again. So I'm gonna stick with A because this way I'm not dealing with any decimals. So the sine of 42 over the side opposite is 22. I'm gonna try to find side C. Remember the sides we're putting on the bottom. The sine of the angle C is 116.9. Cross multiply. So I have C times the sine of 42. Cross multiply. 22 times the sine of 116.9. If I want to solve for C, I need to divide both sides by the sine of 42. So C equals, calculate the top, hit equals, then divide by the bottom. 22 times the sine of 116.9 equals, that's the top. Now divide by the sine of 42, hit equals, my side C is approximately 29.3 inches. So I'm gonna go ahead and write this here, 29.3 inches. Now one way to check your work, okay, just kind of making sure that we were on the right track. Your largest angle is 116.9. Our largest side is 29.3. They are across from one another. The smallest angle was 21.1. The smallest side was 12. The smallest angle is across from the smallest side. This had one solution. We solved it and we're good. Okay, let's look at the next one. They tell us A is 15, B is 25, okay, and the measurement of angle A is 85. I have to find H. H is B times the sine of A. Well, B is 25, so this is what H is, times the sine of A, it's 85. So if I calculate this, guys, if I go ahead and go 25 times the sine of 85, H is 24.9. Okay, so let's go ahead and check this out. Is A smaller than H? A is smaller than H. Well, if A is less than H, there is no triangle that's going to work. If you were to actually use the measurements, use a ruler, use a protractor, all of that great, awesome, fun stuff from geometry, but if you were to use that and try to create the triangle, it doesn't line up. You're not going to be able to actually close the triangle because no triangle exists. Yay! Oh, sorry. No triangle exists, so you don't have to do any calculations. There's no point in calculating something that doesn't exist. So if you get something where there is no triangle, you can write no triangle exists, not possible, no solution, and turn the page. Okay, don't waste any time trying to calculate something that's not even there. Okay, now here's one where it is two solutions. Now what I did, just to kind of save us some time, because I know, I apologize again, your videos have been getting so lengthy. This is one where we are going to see what happens if there's two. So all we're going to do is find the two triangles. If you're like, how do you solve for them again? You can go back and watch the beginning of the notes where we solved. Okay, the first one where we had one solution, side angle, we solved using the law of sines. On the first page of the notes, we solved a triangle using the law of sines. So for this, I just want to be able to show you what it would look like if you had two. I'm not going to make you go through and solve both of them because at this point, I'm hoping it makes sense how you set up the proportions and cross multiply. Okay, so A is 12, B is 31. So again, remember you have to calculate H. H is B times the sine of angle A. Okay, so B is 31. Angle A is 20.5. So if I go ahead and I calculate this, 31 times the sine of 20.5, boom, I get 10.85, so it's about 10.9. Now remember when we're looking at this, there is one scenario where you're going to have two solutions. That one scenario is if H is the smallest value, A is the middle value, and B is the largest. If it goes in that order, H is the smallest, A is the middle, B is the largest, then you have two solutions. And here, if you look, H is 10.9. That is the smallest. So H is less than the other two. Now what comes next? Well, A is smaller than B. So we have that. It goes H, A, and B in that order. So we have two triangles, okay? So what that means is that when we look at this, two different things can happen. We could have this where angle B can be obtuse. Okay, so remember in the drawing when you look at what they're showing you, okay, this is angle A, this is B, this is C. Okay, so they drew, these are the two different scenarios. This is A. Okay, or it could be like this, you guys, where B is acute. And this would be A, and this would be C, and B is across, and A is across, and C is across. So these are the two things that can happen. The main difference is what the heck's going on with B? Is B an obtuse angle, meaning it's greater than 90? Because that's a possibility. Or is B less than 90? That's a possibility, okay? So let's go ahead and label what we know. Let's use this triangle, okay? Angle A, this is 20.5 degrees. Side A, this is 12 meters. B is 31 meters, okay? So I can use the law of sines because I have an angle on the side across from it, okay? So let's solve for angle B because when you have two cases, that's what the main difference is going to be. Is B acute or is B obtuse? And you have to realize that it actually could be both. Okay, so I have the sine of the angle, sine of 20.5 over 12 equals, I want to find the sine of angle B. I know the side is 31. Cross multiply. 31 times the sine of 20.5 equals, cross multiply, 12 times the sine of B. Well, if I want to solve for the sine of B, I need to isolate the sine of B. So I need to divide both sides by 12. And that way I am isolating my trig function. So on this side I have 31 times the sine of 20.5, there's the top, equals. Divided by the bottom, which is a 12. Okay, so this side is 0.90. Now in order to solve for B, I need to do the inverse sine because an inverse sine is going to cancel a sine. So the measurement of angle B, now I go second sine because I had to take the inverse of 0.90. Okay, so the measure of angle B, that's 64.15, so 64.2. Okay, now this is acute. So that means that this would be right here, 64.2. So now here's one triangle, you guys. You could go ahead and solve now, okay? You could use this to find your missing measurements. But right now, all you have to do is find the two triangles. So here, B is 64.2. It's acute. The other possibility, and again, they gave us these measurements. This would be 20.5. A is 12. B is 31. B could also be obtuse. So the way that you figure out its obtuse angle, the measurement of angle B, 180 minus the acute angle, that tells you what the other possible value is. So 180 minus 64.2, 115.8. So those are your two possible measurements for angle B. Okay, so again, because H was the smallest, H was the smallest, A was the middle, B was the largest. That's why it has two triangles. Your two triangles differ in one main area. B can be acute or B can be obtuse. So I went ahead, set it up. I used the law of sines. Okay, we set up our proportion, we cross multiplied, we found our acute angle of B. It's acute because it's less than 90. So that would go with this triangle because just visually you can see that this is less than 90. Well, the other triangle has B as an obtuse angle. So the way to figure out what the other possible angle would be is you take 180 minus the acute angle. 180 minus 64.2 is 115.8. Now you could go ahead and solve each triangle, but again, I just wanted you to find the two so we can move on. Okay, so that's how you would find your two possible triangles. Main thing, you have two different angles for B. One is less than 90, one is greater than 90. Okay, now here is an application. What they're doing is bringing us back to those bearings. So remember when you are maybe a pilot or you're in the Navy and you're sailing a ship, when they talk about directions, they always use bearings. And just as a reminder, your bearings always have to go from a north and south line. So they're going to say, okay, are you traveling upwards or are you going north? And then from that line, are you going to the east or the west? Same thing with the south. Okay, so this is a bearings problem. It says the course for a boat race starts at point A. So this is where you start. It proceeds in the direction south 52 west. So you're traveling to the south. Remember, you have to use that vertical line. Then you're going to the west 52 degrees. So from the south line, 52 degrees, that's how they figure out how to go to point B. Then in the direction, okay, so from B, remember you have to go a north or a south line. They're going south, east 40 degrees to point C. And then finally, they go back up to A, as shown in the figure below. Point C lies 8 kilometers directly south of point A. So we do have one side measurement. Approximate the total distance of the race. So you want to know, okay, the boat goes from A to B to C to A. What is the distance? You guys, this is going to totally take you back to geometry. A and C and B and D. Notice these are parallel lines. If you have two parallel lines and a line that crosses right through them, this is called a transversal. So in geometry, this is where you would have learned about like alternate interior angles and vertical angles and alternate exterior angles and all of those things, your linear pair. Okay, it's the same thing. They're not reviewing it with you because they hope that you remember this. Okay, so that's why I drew this out. These are two parallel lines. This is a transversal. I can find the measurement of angle C because it would have to be the same as 40 because these are called alternate interior angles. Interior because both of these angles are inside of the parallel lines. Alternate because they hop over the transversal. So this is 40. Now from there I can find a measurement of angle B because we know that it's a lot easier for the law of sines if we know those angles. Well, the measurement of angle B, every triangle has to add up to 180. So 180 minus 52 that they gave us minus 40 because we knew alternate interior angles from geometry. Okay, so if I go ahead and I subtract those, I can find that the measurement of angle B is 88. Now what we want to do is figure out the perimeter. We want to find all three sides and add them together. So I can go ahead and use 88 degrees across from 8 because I know the angle and I know the side across from it. And that's kind of the setup for the law of sines. So I would have the sine of 88 over the side 8. I'm going to have to use that twice, guys, because I need to figure out two side measurements. I need to know this and I need to know this. So if I want to go ahead and find side A, I'd have to use angle A, which is 52. So sine of 52 over side A. Cross multiply. So it's 8 times the sine of 88 equals cross multiply. 8 times the sine of 52. If I want to solve for A, I need to divide both sides by the sine of 88. So I'm going to go ahead and do that calculation. So if I have 8 times the sine of 52, that's the top. So hit equals. Now divide it by the sine of 88. I get 6.3. So 6.3 kilometers, that is side A. So as they travel from B to C, that is 6.3. Now I need to find side AB, okay, or also known as side C. How far is it to go from point A to point B? Well, I need to use 40 degrees to do that because that's what's across from that side. So the sine of 40 over side C. Cross multiply. C times the sine of 88 equals 8 times the sine of 40. Now I'm trying to solve for C, so I need to divide both sides by the sine of 88. So C equals 8 times the sine of 40 equals. Now divide that by the sine of, sorry, that's a terrible 88. 88. Yep, making sure. Okay, I get 5.1. So that's 5.1 kilometers. Now that I know all of the sides, actually I solved the whole darn triangle. If you look at this, we know every single measurement on the inside, we know every single measurement on the outside. So technically we solved this triangle. The question says approximate. They know that you had to do some rounding. That's why even the directions say this is an approximation. What is the total distance of the race? A to B is 5.1. B to C is 6.3. C to A, where you end the race, is 8. So if you add those three measurements together, you would have approximately, or we would actually get 19.4 kilometers. I just put the approximate symbol because yes, we did round when we found our solutions. So the race is approximately 19.4 kilometers. Okay, last idea of the day. Now think about when you normally look for the area of a triangle, right? Like when you were back in geometry, when you had to find the area of the triangle, you had to take 1/2 times the base times the height. And remember, your base and your height, the way that you could find those are the two sides that together created your 90-degree angle. Well, you guys, we're not looking at right triangles. Based off of what we're doing today, it's going to be pretty much impossible to find B and H. So what happens is they go ahead and they give us new formulas. This is so fun. Okay, this is the best part of the whole day for me. So I'm going to go ahead and draw this triangle just so I can show you. Okay, so if this is A, this is B, this is C. Across from angle A is side A. Across from angle B is side B. Across from angle C is side C. Okay. You can use the sine function, and that's why this is part of 6.1, because they're showing you different things that you can use the sine for, okay? It says the area of any triangle is 1/2 the product of the lengths of the two sides times the sine of their included angle. So what that means is if you know two sides and the angle in between, you can use a formula and find the area even though you don't know the base and the height, okay? So here's your options. 1/2 times AB times the sine of C. So it's 1/2 times, if you know side A and side B, the angle in between is C. So it'd be the sine of C. 1/2 BC times the sine of A. So this time they're saying you know sides B and C. So it'd be times the sine of A because the angle has to be in between the two sides that you know. Or it could be 1/2 AC. It doesn't matter which two sides you know, as long as you know two sides and the angle in between. It's 1/2 times the side times the sine of the angle in between, and that's your area. So I have one of these because I really think as long as you see the one, you should be good to go. Again, there's some suggested assignments where if you want to try the law of sines, try finding the area of an oblique triangle. Awesome. If you have any issues, there is a Zoom call tomorrow where you can zoom in and ask me some questions and I'll do them with you. Okay. It says find the area of a triangular lot having two side lengths. Okay. So let's say this is 90 meters. Again, not drawn to scale. This is 52 meters with an included angle. Included means it has to be in between the two. So if this is my 90 and this is my 52, the angle in between the two is 102. If I want to find the area, guys, it's 1/2 times the side times the side. So it's 1/2 times the sides times the sine of the angle that's in between. You guys, this is it. You can put this in your calculator at one time. So 1/2 times 90 times 52 times the sine of 102. Your area is 2,288.87 and it's meters and area is squared, or if you're rounding it to the 10th, 2,288.9 meters squared. So again, you can find the area of an oblique triangle as long as you know two sides and the angle that is in between the two. You take 1/2 times the two sides. Okay, it doesn't matter. It's that property for multiplication. Remember, you can multiply in any order. So if I would have said 1/2 times 52 times 90, the commutative property says I'm going to get the same answer. Okay, so don't worry about, oh, it has to be A and then C, or it has to be A and then B. You can go 1/2 B times A and you're going to get the same answer. You're multiplying commutative property. Okay, so all you have to do is take 1/2 times the 2 sides times the sine of the angle in between. Make sure you remember that when you label area, it's always squared. So guys, that is 6.1. I did it in 45 minutes. Woohoo! Air high five, and I will talk to you soon. Bye.